Well, hello again, everyone. We are now starting on lesson 14, outliers. So this is kind of important, and my students here in Mapleton had a hard time trying to figure this one out, and so we'll make sure we spend a little bit extra time on this to make sure that you get it. All right, and so we're going to start out with, and we're going to try to show you what to look for outliers, what the definition is that we'll adhere to on outliers. And so we'll just go ahead and get started. So we start out with this one. It says on 14.1, it says the histogram and the box plot show the average amount of money in thousands of dollars spent on each person in the country, per capita spending for healthcare in 34 countries. So we have 34 countries, and if you add up the 7, the 8, and etc., you're going to come up with 34 for the sample size. So here's your histogram. And then down here they do the same thing. So you have their same scale right here, and you have the same scale down here. And it's per capita health spending. So you're talking about 6,000, 8,000, 10, 3,000, etc. And so per capita health spending by country in thousands of dollars. And so this is just how many. This is how many countries have spending between 1 and 2,000. This one is how many countries have it between 2 and 3,000. And of course, one country out here, just one country between $9,000 and $10,000 per person, per capita. All right. And it's the same idea down here, just a different representation of it. As you can see, 50% of all the countries lie between 2 and about 4.8 thousands. So about between a little over $2,000 and $4,800 per person per year. Now, that's the first question here. Let's look at that. It says one value of the set is an outlier. Which one is it? What's its approximate value? Well, as you can see, it's this little baby right here, all the way at the end. Remember, your outliers are always going to be on the ends. They're not going to. You'll have no outliers in the center here. You're going to have outliers at the very tail end of these things. Okay. So over here on this side, or you're going to have an outlier on this side, but you're not going to have an outlier inside here. So one value of the set is an outlier. Which one is it? What's the approximate value? Well, I think we can all see that thing is an outlier. The approximate value, you could say between $9,000 and $10,000. You could say $9,500, something like that. But you have to realize that the number lies somewhere between $9,000 and $10,000, and it's right there. Which one is it? What's the approximate value? Okay, so it's the one on the end, between 9 and 10. By one rule of deciding the value of an outlier, by one rule for deciding, a value is an outlier if it's more than 1.5 times the IQR greater than Q3. Show the box plot whether or not your value meets this. Okay, so let's talk about this definition. They don't do a whole lot of. They have a kind of a disservice here as to what we're doing on here. So we're going to go and actually do the math on this thing for how to find IQ for finding the outlier. So first step, number one, find the IQR. Well, the IQR here is going to be Q3 minus Q1, just like it's always been. So let's see what those are. Well, it looks like we're about 4,800. Well, about 4.8. And I'll go 2,100 or 2.1. So 4.8 minus 2.1, that's the scale that we have here. And when we subtract that, we have a 2.6. That's the difference. Or excuse me, 2.7. Whoops. 2.7 is your difference. Now what you're going to want to do is take that IQR. Oops. Take that IQR right there. You're going to go, it's either going to be Q3 plus that Q3 plus 1.5 times this. So plus 1.5 times 2.7. And you're going to take Q1 and you're going to subtract it. 1.5 times 2.7. Okay? So let's go and do a little bit of math here. All right. So it looks like you got let's just start over here, Q3. I'm going to take 1.5 times 2.7. 1.5 times 2.7. Okay, so we get right about 4.05, about 4. Let's go with about 4. And your Q3 is 4.8. So that turns out to be about 4.8 plus 4.05. But we'll say just 4 and just be done with it. So we're talking 8.8. Okay? And then Q1, you're going to take that Q1 value, which is 2.1, and you're going to subtract that same amount, that 4.0. All right? Well, if you notice, 2 minus 4, that's a negative number. So it's going to stop at 0. You're not going to be getting a negative number down this way. Nobody's showing up to the hospital being sick and then getting paid to be sick. It just doesn't happen. They pay the people who work there, but they don't pay patients to show up to get sick. So this one down here, you're taking Q1 and you're moving it down here and you're saying, oh wait, that outlier doesn't lie beyond that. So if I had like a little red line here, okay, that is the IQ1 minus 1.5 times the IQR. Right there. Well, this line doesn't extend beyond it, so it's not an outlier. All right? The outliers would be outside there. It's not. Okay? Let's go this other direction. Let's take this and let's go over to 8.8. Right about there. All right, so this is Q3 plus 1.5 times the IQR. All right? And now you see right here, that is outside. This one was inside. It's okay. That is outside of your limit of that 1.5 IQR. That's an outlier. All right? So that's what they're asking for about that. So when you get a question like this one, right, when you go through this, you actually you find out that you have an outlier on this thing. Show on the box plot whether or not your value meets this definition of this outlier. So I don't. So it says yes, it is. I'm going to go and erase this because I think I got a little bit better explanation with my ink pens. So we'll just move on there. All right. So yeah, you got an outlier. Look for what this interquartile range is. Multiply by 1.5, and then you add it, subtract it to your Q1 and Q3 to extend out. And if your little whisker lies inside of it, you're okay. But if your little whisker lies outside, it's there as an outlier. Okay. So let's continue on. All right, here's your next page. This is page 100. So you see you have a whole bunch of numbers here investigating outliers. All right, so what they want you to do is to take this data set, and they say use the data set to create a histogram and box plot from the warm-ups. Right? They're going to want you to use technology to find the mean, standard deviation, and 5-number summary. That's not so hard. We can easily do that on Google Sheets. The maximum value of this data represents the spending of the United States. Should your per capita healthcare spending in the United States be considered as an outlier? Explain your reasoning. So all these data right here is what was used to create that right there. That's where it came from. All right. So nice little histogram, nice little box plot. There's the numbers, the raw data. Okay. So we can go and work through that and look at that a little bit closer, but we need to use some technology. So what I need you to do is to go put these numbers into a Google sheet, and I want you to go ahead and find these: the mean, the standard deviation, and the 5-number summary. All right. So that's what you need to do for this one, for the 14.2. The maximum value for this data set represents the spending for the United States, and they ask some more questions. Below, the outliers should be removed without considering their cause. Important values to see see how influential outliers can be for various statistics. Remove the value of the United States from the data set, and then run the numbers again. Okay. So we're going to go and put this into a Google Sheet, and you should do the same for your lesson. and we'll go back and we'll come back and look at this then. Alright, and we're back, and so now we have, if you can look at this little screen here, I've placed all of these numbers in an array here. So I start with A1 all the way down to A34, and I put in everything that they asked for. They asked for the mean, the standard deviation, and then the 5-point summary. Okay, so your mean, there's your equation that you're going to have to work with, and your standard deviations right there. And then your min is just a command, just equals min, and you put in the array. Q1 is a quartile, that's the command, quartile. You put in the range, and then you put in like a little number 1 here for the first quartile. The median is the same thing as the second quartile. If you typed in median, you'd get the exact same number. Right? It's the same thing. And then Q3 is the same quartile, A1 through A34, with the number 3 here for the third quartile. And then, of course, your max is just equals max. All right? And so you have all your data right here, and you can start making a box plot on your computers or else by hand. I just want to make sure that you guys knew how to go and get these numbers. And so it goes through and it asks a few questions here. Use technology to find these numbers. We just did that. Number 2 says maximum value of this data set represents the maximum spending of the United States. So here's the rest of the world, and here's the United States, 9.89. Unlucky us. Let's see. Should the per capita health care spending for the United States be considered an outlier? And the answer is yes, because it does exceed that 1.5 times the IQR. It is outside that range. All right, it is. That was the little thing I put a red circle around. That was the outlier. That's the U.S. All right. Although outliers should not be removed without considering their cause, it is important to see how influential outliers is for various statistics. Remove the value of the United States from the data set. So I want to make sure I kind of keep these, and so what I'm going to do is do a lot of copy and paste. So I'm going to go and take this thing, and I'm going to go and take all these numbers here, and I'm going to copy it, Control C, and then I'm going to go over just a little bit and up, and I'm going to paste it. Okay, so it's all the same numbers and all the same data. Everything else is the same. I'm going to do one little change. All right, I'm going to go and take this guy out, and now I'm going to go and look at this. It still has the 34 in there, but this stops at 33. So I have to go and take this and put in a 33, right? And now it's going to change that ever so slightly. So what I want to do now is I'm going to have to change this little array. So I'm going to copy and paste that into the rest of these commands. All right? So standard deviation now is right there. Or I could just go up here and just do that. Just change the 34 to a 33. That's done. And that should be all of them. Let's check. D1 through D33. Yep. 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 So let's see what changed. So I got rid of this one little sheet, and what happened to it? Well, it dropped the mean from 3.73 to 3.54, a rather significant drop. Standard deviation dropped, so it became a lot less variable. The min stayed the same. Q1 dropped a little bit, 2/100ths. Your median dropped 0.1, so a little bit. Q3 dropped a little bit. But then your max dropped from 8.89 to 6.65, so it was a significant drop. So as you can see, when you got rid of that outlier on the high end, everything moved in the same direction, namely down. So it was really skewing all of these events. All right. So that was the big thing to go and look for there. All right, and that's all I'm going to have for today. I don't have anything more on this one. I wanted you to just kind of see that. So we're done with 14.1, 14.2. And that's all I've got. Thank you.